Hello everyone. So in this video, let us go over the first four problems from the CodeChef Starters 2021. So let's go over them. The first problem is Devendra and water sports. It's a very simple problem. It just states that there is a person Devendra who wants to go out with his friends. He has a budget that is of Z, that is rupees Z at the start of the trip, and he already spent Y on the trip. That is fine. Now, let's say that he planned on a trip. He has a total budget of Z rupees, and he spend Y on the travel. Then there are three kind of water sports that one can enjoy at that particular place. So he was into Goa. So there are three water sports. Now, with the prices A, B, and C, he wants to try each sport at least once. If you can try all the sports at least once, output yes, else no. So you can easily say that if he has Z rupees and he has already spent Y on the travel expense, if you want to at least do all of these sports at least once, so he should be having at least A plus B plus C, all of that amount at least once. I hope you get the point. So let's say that all of these amount are, let's say, 2, 3, and 5 rupees. So he, after removing out all the travel expenses, he should be having at least this total of A plus B plus C amount left with him after from Z minus Y. Hope you get the point. So that's the whole thing. Very simple, just solution. So I'll show you the solution actually for this. So solution for this, as you can see, where is the solution? Yeah. So as you can see that he has, if the total of Z minus Y subtracting out the addition of A plus B plus C, if it is greater than or equal to 0, then you just print out yes, else the answer is no. So in this line, I'm just taking out the input and then I'm just printing out the answer. So you can also use this ternary operator to do that. So that's the whole solution for the first problem, nothing much complicated. The second problem states that there is a COVID and theater ticket problem. There is actually a hall, you can assume, in which there are people who will be sitting and watching out the movies. The problem is just that you are given the row number and column number of that whole row, like the whole hall, I suppose, and then you just have to tell that how many people can sit in that hall following the COVID rules. Now the COVID rules are such that if two people are sitting in the same row, there must be at least one empty seat between them. So if there are two persons sitting in the same row, then there should be at least one seat that is empty. As well as if they're sitting in the for respect to two rows, as you can see, like in the first and second row, there should be at least one row difference between any two rows. So if you're talking about two rows, then any two rows should be having at least one or more difference in rows between them. Okay, so I'll tell you in drawing form. So let's say that if there is like this, so let's say that I'm first trying to occupy people in the first, let's say first row. So I can put a person here and I can give some space, because I cannot just put the cannot place the next person just right beside the first person. So I should be giving some space. So let's say if I place the second person here, so I cannot place a person here. Now if this row is occupied, as you can see, now I cannot place any person in the above row, because the row is also be such that there should be some row space also. Okay, so the other person should be placed in any row above that. Okay, so let's say that if I just optimize it or to optimizingly placed people, so I will be placing one people here, one people here. Again, I cannot place any people in this row, so I will placing one people here, one people here. Hope you get the point. So that's the whole thing, that you are given some n, like how many a number of columns and how many number of rows, and you just have to tell that how many number of people you can place in the maximum configuration possible. Now what you can see here is that, let's say for even coordinate, let's say that if you're talking about any of the even number of, let's say column, let's assume. So if you place in the first row, then you have to give some space, so you will just give one column space, then you can place in the second row. But let's say that there are odd number of columns, so it's better to place 1, 2, and 3. So I hope you get the point. So it's just like the seal of n. Okay, so it's mean that if so n is, let's say 4, so 4 divided by 2, you're getting the half, that is equal to 2. But 3 divided by 2 is actually equal to, or so let's say the total number of rows are 5. So 5 divided by 2, if you just find out, it's actually 2. But you have to find out the seal. Okay, so it's like 5 divided by 2, the seal of it. So for better way to finding out seal is, if you have n, you just add 1 to it and divide by 2. Okay, so that's the best way to find out a seal. Okay, if you have, let's say, n and you want to find out a seal for it, okay, either you can find out the dividing by 2 or any number. Like, I'm just talking about n, actually just 2 only. If you have 2, if you divide it by 2 and then find out what is the seal, like if there's some points or not, it's better to just add 1 to it, and then whatever the number is, that's the seal for n divided by 2. Fine, so that's the whole thing. And similarly for rows and columns, so the best way is actually just, if you have n rows and m columns, so n plus 1 divided by 2, let's say, column, into n plus 1 divided by 2 number of you can say rows, and just that's the whole thing, because how many people I can sit. Okay, so that's the whole solution for this problem. So I'll show you the code part now. So yeah, number of columns and number like half columns and like half rows, I just multiply all of that. So that's the whole second problem. Third problem is also, it's just a little bit of observation. It just says that there is a n by n grid, okay, and n is odd actually in the problem. So what the problem statement states that there, because it's a n by n grid, there's always a center point. Center point means that, as you can see, that is this unique center point of this whole grid, that is n plus 1 divided by 2 and n plus 1 divided by 2. That's the whole center point of this whole grid. Fine. Now, like, you are placed on any of the block, like you can start, you're given the starting point on which Akash will start on this whole grid. And now there are two types of like moves you can do. He can move along any of the diagonals, or he can step one step horizontal and vertical with the cost of 1 gold coin. Like, you can move along the diagonals without any gold coins, but if you want to move along like one step horizontal or vertical, you have to give 1 like gold coin. So that's the whole problem. Now you have to just minimize the number of gold coins you are required to reach the center. Fine. For reaching the center, if you do some diagonal moves, that is free. Okay, but if you do some horizontal or vertical moves, that are costly. Now, the main things in such a problem is, or in any problem is, I first try to draw things. Okay, so what you can see here is that if I draw out a grid, let's say, so it's like 1 2 3 4 5, so 1 2 3 4 5. So as you can see, then this is the actual center point of this whole grid, as you can see. Okay, so let's assume that if I somehow start from this point, let's take some example. Then can you, because I can move in a diagonal fashion, can you see what all blocks I can like reach to? So as you can see, I can reach to this block, I can reach to this block, because I'm just moving along the diagonals. Okay, or let's take some another pen, actually it will become more clear to you. As you can see that I can move along the diagonal. Just forget about the center point, just see how many points you can move along. As you can see that I can move to this point, moving along this diagonal, and then I can move to this also. Then I can move to this, I can move to this, I can move to this. Okay. So what you can see here is that if you start at this point or this point or this point, like they're actually same. Like, you will always land upon all of these points, and also you can land upon the middle point. Now, okay, so what are actually what you can say, if you are given any of these like as a starting point, can you directly see that on what points you can land upon? As you can see that this is the coordinate 1,1, this is 1,3, this is 1,5. Okay, similarly this is actually, as you can see, 2,2, or as you can see 2,4. Now what you can observe here is, and this is actually like 3,1. So what you can directly see here is that these are both odd numbers or both even numbers. If both are odd numbers, as you can see, because like both of them, as you can see, if I'm landing upon this, both of them are like one, like the first column, and then the odd number of rows. And similarly, if I go to the even number of rows, then even number of columns. So it means that if I move along, like if I somehow land, or if the starting index is such that both of these index, that is x, y, of the starting point are both odd or both even, then I can directly obviously land upon the middle point, like because any one of them I can directly go to the middle point. Hope you get the point, because this middle point is obviously coming in this like mesh. But if the grid is such that 1 2 3 4 5 is such that if I land, like if I start from the other point, then as you can see that I will go to all the like boxes that are like apart from this grid point, like not in this grid. So it means that I will land upon all the positions like this. So these positions. So which means that if in that case I will not like reach the middle position in any way possible, but I can get to closest to this. And if I get too closest to this, I just want one step, like one gold coin to reach the middle, because I can move in any horizontal vertical direction just giving one gold coin. So I can come as close to the middle and just use 1 point. So in which if any one of them is like, if both of them are even or both of them are odd, I can directly reach the middle point, or else I will require one gold coin only to reach the middle point. That's the whole logic for this problem. Nothing more complicated. Got it? So let us move down to the code part. For this actually also have the code actually. Yeah. So as you can see that I just take the input of n, that is the grid size, and x and y, that is the starting index. I just check that. I just write down the function for that, because I could have written down here also like the conditions, but I just thought why not just use a function. So what you can see here is that that's a both odd and both even function. I just give x and y as the input of that, and this both odd, just check that whether both of them are odd or both of them are even. If that is fine, then it means that I do not require any gold coin to reach the middle of this whole grid. I will just return that out, or else I will return like 1, that is I required 1 gold coin. Fine. And then the last problem, that's not a good problem. So what you can see here is that the problem statement, I'll go you with the simple terms. It says that you are given an array A consisting of n integers. Now from an array A, we create an array B, fine, containing all pairwise, bitwise and of the elements from A. So you will take every pair of A element, like A array, and do their bitwise and, okay, and then form all the elements of array B. So as you can say, if you form every bitwise pair, it will be n into n minus 1 divided by 2 pairs. So the B consisting of these much elements, and each of them are these AI and AJ and operation. Now in array B, what you'll do, we'll repeat the following process until one element is left. Now what you'll do actually is let the current maximum and minimum element of array B be x and y. So you'll find out the maximum and minimum element of B, that all the elements, and remove x and y, and inserting x or y inside the array B. Got it? That you first take the array A, do every bitwise and of every element, like pair in A, form an array B. Now in B, what you can do is you first, like you will keep on iterating doing this step, in which you take the maximum and minimum element in array B at any current given point of time. And then what you'll do, you will find out their OR, put that number back into the array, because one number is subtracted out. You have taken a pair and you have now inserted a number again, that is the bitwise OR of both of these elements, and you will keep on doing that until only one element is left. Now determine the last element. That's all problem. Now the problem seems very difficult to you. It feels very difficult to me as well when I first read it. I thought that, okay, that's very tricky, like how can we find it out? But there are 2-3 things which you can directly observe, like by going through the problem statement. I'll tell you. Just move this out. Let's take one example actually to even make it more clear. Let's take some example from here itself. Last one, let's take 4672. 4672. Now I do not actually know the bitwise and of all of them, but I'll just take, let's say, x1, x2, x3, x4. Now what you can directly observe here is that when you do bitwise OR, what is bitwise OR of x1 or x2? It actually means that if any one of the bits is set, then it will be set in the final answer. Now what does it actually mean? It actually just means that what you can see here is that okay, if any one of the numbers, so let's say that if you have different like n into n minus 1 numbers in array B array, you have the B array, okay, which has n into n minus 1 elements. Okay, now what you'll do is you take any two numbers, that is the maximum and minimum number, find out their OR and insert that into the array again. Now what you can observe here is that in that element, or in, like if you take any element, then you are actually taking out two elements and then taking out their OR. Okay, so in that process what you are doing here is that in the end you have done OR with all the elements. Like you're taking OR with all the elements, because in the end OR will be done for all the elements, because only one element will be left. So OR generally do is that if any bit is set, it will be set throughout the process. Because see, if in any bit is set at any position in the whole array, let's say that I have some numbers, I will just put them in some bitwise number. Let's say these are the numbers in the array B, let's assume. Now if this bit is set, or let's say that if this bit is set, or if I just move out this whole part, if let's say only this bit is set in the last position, then also it is fine, because this bit is set, so it will be set in the last answer only also. Why? Because we are doing OR. Okay, if when we do the OR of this number and this number, whenever they will be paired, then this bit will get set. Whenever that number will get, a new number will be inserted, and in that number one will be set it out. So that set bit will be set in the next term also, next term also. So in the end, that bit will be set in the final answer. In the final answer, that bit will be set. So it means that if any number is there in those n into n minus 1 number that has a particular bit set, that will be set in the final answer also. Hope you are with me also. So my final observation is, or like my final goal is to find out what all bits are there, okay, in those n into n minus 1 numbers that are set, like, because in any of those elements, like, so let's say that I have, like, let's say I have 10 elements. So in 10 elements, I just have to check that. So in all the 10 elements, let's say there are 10 bits for every number. So for every number, there are, let's say, 10 bits. So I have 10 numbers. So all of them will be represented like this. So all of them will be having these bits. Okay. So these are 10 numbers, let's say. Okay. So I have those bits. I just have to first check that if these 10 numbers are there in array B, if any number has, let's say, the first bit set, so it will be set in the final answer. If all of the numbers will be having the second bit unset in all of the numbers, then it will be unset. If any number has the one bit set, then it will be set. So it actually means that in any of those n to n minus 1 numbers, that bit should be set. I just have to find out. Now how can I find out that thing? It will be set. Because the constraints are very long, I cannot do that. I cannot find it out for every pair actually. Constraints are very long. How can I do that? Now the next thing which actually strikes you is that they are forming pairs. Okay, and that is also AND. Now in AND, how will we say that any number will be there that is a bit is set in that particular number? In AND, what you can say is, because I am forming out pairs, if the numbers are like this, so this will not form a bit set bit, because in AND, if you are doing an AND operation of both of these numbers, both of these bits should be set. Then only this bit will be set. Hope you get the point. So if I have n numbers, okay, and I will be forming a pair, if in any of those n into n minus 1 pair, any one of them will be having that set bit, it is good. How can I find that? So I've just find out that because there are n into n minus pair, like n minus n to n minus 1 pair, which means that every two numbers will be forming a pair. Okay, so which means that if any two numbers are having a particular bit same or like set, then obviously they will be forming out a pair, and they will be forming out a pair, so that will be bit will be set in the B array. Hope you get the point. So I'll tell you with example actually, so that it will become more clear. So let's say that there is a number that is, let's say, like this, and there's a number like this, there's a number like this. Let's say that there are 3 numbers. Okay, now I just want to check that whether the first bit will be set in the, like, any number will be there in the B array that has this, like, the 4th bit or like the 0th bit set. How can I check that? What you can see here is, I will just find out the total number of bits that are set in the last position of all the numbers. I just count out. As you can see, there are 2 bits that are set. There are 2 bits that are set. There are no bits that are set. There are 3 bits that are set. This number just denote out how many bits are set in all the numbers in the first position, the second position, third position, fourth position. Now what you can see that these are two numbers that are having the last bit set, which means that because they are two numbers, which means that whenever they will form a pair, they will make this bit set in their final answer, because they will be doing an AND operation. And because when they're doing an AND operation, that bit will be set, and that will be in the B. And because that will be in the B, that B will be having that particular bit set, and it will transfer that into the final OR answer. Got it? But this number doesn't have any bit set. So whatever pair I will form, that bit will not get set in the array B. Even if there is a number that is like this also, then also there is only one bit that is set in the in the second or third position. So they will not be transferred, because they will not be forming any pair, okay, with the numbers that will be having both of them. This bit will be set so that they will form a pair. Hope you get the point. So I just have to count out how many numbers or bits are there for every position for all the numbers. If the number of them is greater than or equal to 2, then they will eventually form a pair, and they will send there in the B array, and they will form a pair, and that will be transferred to the OR, and then the answer will be found out. So I hope you get the point. So that's the whole logic for this problem, that you will first count out the number of bits, and then that will tell you that particularly bit will be set in the final answer or not. Because if this bit is set, which means that will be transferred in B, and from B it will be, when we are doing OR, that bit will be transferred in the final answer also, and then that bit actually will be in the final answer also when all the numbers are doing OR also. So that bit will be there, this bit will not be there, this bit will not be there, this bit will be there. So the number will be having this bit as set, these two bits are not set, and this bit as set. So that's the final answer after doing all the OR operations on the B array. Magical, na? So that's the whole answer. So let us move on to the solution part for this problem also. So where is the solution? Yeah. So what you can see here is that I've used 30, but you could have done for 10 also. That's not too much, because they are only integers. So what I've done here is that I've taken the input of all the numbers. Then I just have to count out for every bit position for every numbers, that whether how many count of bits are there that are set. So that's the count vector, iterating over all the numbers. For all the numbers, I'm iterating over all the 30 bits. Well, 32 actually just use 30 only. So I'm just checking that whether for a particular ith number their jth bit is set or not. I'm just incrementing the count, and final answer is the final answer that will be formed after doing the OR of all the numbers in array B. That is, if the count of the ith bit is greater than or equal to 2, so that they will be forming a pair, and that particular bit will be in the B array, and B array will actually, when we are doing the OR, will be in the final answer. That will be sent. Then only I will add the particular set bit into the answer, and just appending that in the final answer, and just printing out the answer. That's the logic for the fourth problem also. So these are all the 4 problems. I will be posting more videos from CodeChef, so stay tuned. Thank you for watching this video till the end. I will see you next one. Till I keep coding, and bye.